to be doing this after the news about John. Those that work with John will know what, as others have said, what a great guy he was. In the moment's silence there, I could just see John laughing. So I hope, John, wherever you are, you're looking down at this and laughing. So there's some light-hearted bits of this. It's a bit about, I was asked a few years ago, a couple of years ago actually, had I been involved in any derailments? So I started to list them out, and I got to 50 odd, and I thought I'd better stop now, because as a track engineer, it's starting to get a bit embarrassing. I got the job I was going for, and I've managed to get a few more derailment investigations in since then. So, so this is a chronological order of some of the derailments that I've had some involvement in. I'm pretty pleased to say I don't think I've caused any, but it's just some involvement. So if I can get this to work. So keep it on track. You can't park here. And why I say you can't park here, I mean, that's come from my son and my daughter, who are often moaning about people parking in front of the drive and things like that. And well, actually, it's me that's moaning about them, and they pick up grumpiness and moaning. So this is a bit of a follow on to that. And they have a good company, that is. Mm-hmm. If only they could work the clicker. So I started on the railway 46 years ago. During that time, most of that time has been spent overseeing the safe operation, design and maintenance of the railway, particularly the track, and keeping trains on the track, which as track engineers is something we really want to focus on. But sadly, things do go wrong. And as I said earlier, that's I have been involved in a number of derailments in my time. And so this is a review of some of those and some of the things that we've learned from some of those as well. And a lot of those we've improved. I will get this right. It's an age thing. So actually, my first attendance on a derailment wasn't. I wasn't actually working on the railway. It was a couple of years before I joined the railway, and it was a derailment at Watford, a crash actually at Watford. 1975 on the West Coast Main Line, an up passenger train struck a metal stillage from a train travelling in the opposite direction, causing it to derail. The train was then struck by a down sleeper train, causing that too to derail, and the loco and leading carriages going down the embankment. And on the right-hand side there, it's a bit grey. In those days, didn't have much in the way of colour photography, but these are photos that I took. And you notice this was, I think, 2 days after the derailment, they were running trains past it. Whereas today, if we had a serious incident like that, the line is often blocked for a week or so after, while investigations go on and recoveries go on. Sadly, one of the drivers was killed in that incident. But there's the metal stillage that came off of one of the trains, and it was struck. One driver was killed, 11 injured, including 8 of the passengers. What it highlights to me is the need to ensure that the contents of wagons are correctly loaded and adequately secured. I had no idea at that time I would be working in track years after that, but there have been cases where things have come off wagons and trains have struck them since. So there's also the old Department of Transport accident investigation report there. Some of these, and in fact a lot of these incidents that I'm talking about, there is a lot more information in either the RAIB reports or the Department of Transport reports. So joining BR, I always laugh. I started in something called the Crow's Office, and the Crow's Office was the computerised renewal of way office. And I spent 6 months in that office and never ever saw a computer. Now, just makes you laugh today because we can't survive without computers. So anyway, that's I moved on from there into the drawing office, PWI as it was called, and did surveys, including drawings, designs. So what's that got to do with derailments? Well, in those days, the drawing office had to go out and do drawings of derailments and also any incidents. So if people were killed, for the coroner's court, we had to do the drawings of that. There was a nasty little X marks the spot where the person had been killed. But we were supported in those days by a fantastic team at Derby. Derby Research had their own derailment investigation team. And the particular guy that is still around, and I've spoken to Mike last year on one of the PWI training sessions. Mike McLaughlin is still doing some training on derailments. Fantastic. So moving on, 1978, I've been on the railway a year. I went to my first real derailment, which was at Grays. 45-ton oil tanker wagon or wagons were derailed on a track twist on a wet spot. And the next year, there was another one at Brentwood, and you'll see a stunning young guy there. In you notice the PPE in those days was just an orange jacket that you fold up and keep in your pocket. If you worked in the drawing office, you really needed a white Mac like that and a briefcase to go with it. In front of me was the lookout, Sid. He was in the Hazell gang. I'm not sure he looked out for many trains, but he was a wealth of knowledge if you wanted to places to eat at lunchtime. These two photos are actually of the Brentwood derailment, and you can see the 45, one of the tankers on its side up the top. In those days, there were a lot of short wheelbase wagons running around and very prone to twist type derailments. Fortunately, these days we have very few short wheelbase wagons, so I'm not saying that we don't have twist type derailments, but it's reduced the risk quite significantly. And the bottom photo shows the derailment actually occurred on the country end of the platform on the up main at Brentwood. Some of the wagon components, and you can see a wheel set there, that probably weighs about 2 tons, finished up on the platform at Brentwood. So very lucky that nobody was seriously injured through it. The twist was actually caused by track staff correcting level 2 faults. So those days, a lot of faults, in fact, probably all faults were corrected under traffic. These days, probably none under traffic. So going on to 1980, there was a freightliner derailed on the Down Main at Chapel Heath. That was caused by poor track top on wet spots. I suspect today we would have called that cyclic top, but that cyclic top wasn't a statement that we were familiar with in those days. And there was also a derailment at Stratford Central Junction. Now that photo there is Stratford Central Junction of a more recent era, because you can see the new buildings and in the Olympic Stadium area. But on that junction, there is a front to front arrangement with a reverse on it. And before, the old layout, I think, had, Jim will correct me, had 5'5" fronts on there, and I think they were an A and a B switch. So very, very sharp turnout switches, a bad reverse there. So we had a freight train derailed due to buffer locking on that sharp reverse curve through the junction. Restrictions were imposed on the configuration of certain vehicles through there, and it was eventually remodeled. However, not before we had 2 brand new Placer USP 5000 regulators derailed on the same junction. These embarrassingly were on delivery, and there you can see a very proud PWI supervisor, track section manager now, Peter Hawkins, who was relieved that it wasn't actually his track condition that caused it, it was the track design that caused it. So as a result of that, standard 049 now, which is the track design standard, probably got a longer number, it might be 2049, but most people still call it 049. Section A75 now has a section in it on buffer locking considerations, and B3.3 a section on follow-on turnouts. So we have learned something from these type of incidents. So if you're doing design, try and take those into account. This was an interesting one, 1981. I used to go to the depot at Leighton to inspect parts of layouts, train consists and so forth. And while I was in there one day, a freight train derailed, exiting the track depot. I was the only one that witnessed it. And as it was leaving, it jumped off, then hit a set of trailing points and jumped back on again. The only evidence really on site was it lost one of its buffers. So there was a buffer line in the forefoot. I managed to stop the train before it went further on. It was going the depot there. Not sure if this works very well, this pointer. The depot there is where the arrow is, and it was coming out and round onto the main line. So I managed to get it stopped around here before it hit the main line and caused any problem. But again, another short wheelbase wagons. These were Grampus wagons, which a lot of the engineering trains consisted of in those days, particularly for spoil and carrying sleepers and timbers. The cause, combination of fish plate strike, S&C block strike, and track twist. The rail was very heavily worn, and the flanges of the wheels were striking both the fish plates and the S&C. 1983, I was still in the drawing office, but in those days, we used to do the initial survey. We would do the design. We would go and inspect it on the layout ground, and then we'd be in charge of the technical installation on site. And this is another young photo of me overseeing the installation of the junction. And you can see there, the top left photo shows how S&C used to be installed. It was piecemeal, like a huge jigsaw puzzle, and each timber was positioned to markers on the rail. And if you were lucky, there were timber laths that came out with the layout. A lot of them got stolen and taken by I won't say who, but other good bits of timber that were used at home. So you can see there, lovely junction taking shape. That was in 1981 when that was relayed, and I was in charge of the renewal. In 1983, we had a derailment on the junction, which I have to say, knowing that you've had a derailment on one of your junctions is a little bit of a, well, I won't say heart-stopping moment. I've had worse than that, but a worrying moment. However, the cause wasn't the track, it was the train. And in fact, it was a broken Gibson ring. And those that don't know what a Gibson ring is, and I didn't until this incident occurred, the Gibson ring is actually the ring that retains the tyre on the wheel. If you've got a separate tyre on a train wheel, then you have something like, it's like a huge circlip that clips in place and holds it. And this actually came off, broke just before it was coming to the junction. The wheel flange took the wrong side of the crossing, and fortunately the train was slowing down to stop in the station, but it caused a derailment. Very little damage actually on that, but it was it's embarrassing to have a passenger train off, to say the least. In 1984, I was the PTO at Liverpool Street to what we call the PWME in those days, the TME, and we had a crack express, what we used to call it, the Essex Express, from London to Clacton, Liverpool Street to Clacton, 4 o'clock every day, well, every weekday. Managed to derail that in platform 12. I was still in the office at 4 o'clock. Everybody else had gone. And it was literally just above the platform where the derailment occurred. So I was actually the first engineer on the scene. Probably wasn't the first on the scene because there were hundreds of passengers on the train. But after supporting the safe evacuation of the passengers, getting them back on the platform, fortunately the rear of the train was still in the platform. Soon established the cause of being wide gauge on decayed sleepers and timbers sleepers. That area of the platform is under what used to be the Parcels Bridge and a very dark area. So in terms of inspection, it was quite a difficult area to inspect. So, and it's interesting, a lot of things during my career have come round again, full circle. Liverpool Street comes up again in darkness in one of my later incidents. Again, nobody injured there, fortunately, but very embarrassing. 1986, up Main, we had at Ilford, a container train derailed on poor track geometry. Again, a wet spot. So again, wet spots were featuring really quite heavily on derailments in these times. And I have to say, we had an awful lot of wet spots across the network around these sorts of times. This particular one was due to block drainage through the platform. So we were doing quite a bit of maintenance on drainage in those days, but clearly we hadn't done enough at Ilford to identify the risks there. 1987, Forest Gate Junction, a passenger train derailed when it passed the signal at danger and collided with the rear of the train in advance. In that particular one, there were 14 people injured. So the incident occurred in October, leaf fall season. You can see the top photo there. On top of the retaining wall, quite a bit of vegetation. Still pretty green actually in that photo for October. But it resulted in, there were damp conditions in the cutting, and that resulted in lack of adhesion. And you can see there the photo that I took on the day, the railhead was completely black. And I have to say, that is something now that we've brought in a lot of railhead treatment, a lot of grinding. So if you get grinding, you get a finer contact band, which tends to bite through the leaf mulch. It's not the grind, it's not that you grind the leaf mulch away, but you get a greater impact force or a greater force on the rail. So we are much better, and of course we've got the rail treatment trains as well running about now, which we didn't have in those days. In those days, trains were fitted with sanders, but one of the things that we didn't really appreciate was that sand actually is an insulator as well. So it can insulate from a track circuitry point of view, but also a return current point of view, where you've got overhead lines and so forth. So that came out, I sat on the inquiry on that, and that came out of the inquiry. 1992, February the 14th. Why have I put that there? It's Valentine's Day, and there's better things to be doing on Valentine's Day than going out to derailments. We managed to derail an empty coaching stock, leaving East Ham Depot, and it ripped up about half a mile of plain line, badly damaged some S&C and also a bridge girder. And that girder is still damaged today. It's obviously very safe, but the marks and the dents are still there today. So that one was caused by wide gauge on track within the depot, and it's, you know, we focus a lot on the main running lines, but it just highlights how important the exits in particular are to depots and pieces of track that run parallel to main lines. It's important that they are maintained to a good standard as well. And of course, in those days, 1992, it was all BR. So it was all my maintenance. By that time, I think, 1992, I'd just taken on the role of permanent way engineer, LTS, London Tilbury and Southend line. So I picked up the responsibility for that one. I spent the evening assisting recovery and planning repairs, and a night out with the Easterbrook brothers, if you know the Easterbrook brothers. I can think of better things to do on Valentine's night. 1993, must have been a cold winter. East Tilbury level crossing there. managed to derail a passenger train in snow. The snow was so heavy that year, it built up, and there are quite large battery boxes underneath some of these electric multiple units. The actual unit lifted up on the snow on the battery box and derailed the vehicle as a result. Again, never came across a snow-caused derailment until that one, and 2 months ago I had cause to go to another one, so I'll pick that up a bit later. 1994, big year, privatisation came along. In privatisation, I got the job as the permanent way engineer for the southwest zone of rail track. I didn't even really know where Waterloo was. I think the first time I'd been there was for my interview. But a chap called Mike Sound, I don't know if you're listening, Mike, but Mike very kindly offered me the role over here, and it was a great time, apart from a few incidents that occurred. And the first of these was in the first year, which was a passenger train derailed at Waterloo on wide gauge in S&C. And what we discovered is that the area around Waterloo, if a lot of you will know it, it is very, very difficult to inspect robustly. And at the time, it was being inspected under traffic. So the poor patrolmen were jumping in and out of trains, didn't have much time to focus on what the real issues were there. And looking back, I really don't know how they robustly did it. So
C section. Top C section.
Yes, some of it. Well, yeah, some of it was.
That gave you centre right.
Some of it, and that was one of the things that we introduced after this derailment. Was we blocked one line out to Vauxhall and then Vauxhall out to Clapham, which was the place of safety. So it was planned that there was the patroller was never walking over more than one track to a place of safety, and that block line progressively moved over as the week went on. 1996, again, I was in the office late in the afternoon. Don't know why I stay late in the office, or I did, but I got a call. There's a train derailed at Farringdon. Well, actually, the southwest zone didn't cover Farringdon, but I was the nearest rail track engineer about, so I went, and this train had derailed on a newly installed switch at the country end of Farringdon. That junction's no longer there now. Thameslink has taken that out, but at the time there was I think that was another AV switch, newly installed, and a newly turned wheel had derailed on it. Wheels, when they're turned, are very soft compared to what they work hardened to, and they progressively get harder during the course of their life. So once they're turned, that work hardened area is removed, and you get a nice profile to the wheel, but it is fairly soft. And what had happened, this switch, I think that was a manganese switch, it had a sharp gauge corner to it. That sharp gauge corner had dug into the tyre, and it was the tyre of a motor coach, and that effectively allowed the wheel spiraled out. The sharp angle dug into the tyre and literally allowed the wheel, as the power was put on, to climb out. So that type of failure became known as the Farringdon Edge failure, or as we call it now, hazard 5 failure in what was rail track standard 053, some longer number now, 2053 or whatever in the Network Rail standard. But hazard 5 still exists, and like you'd expect, there's another 4 hazards before hazard 5. 1996, the southwest zone merged with the south zone in rail track days, and I became the track engineer for what was then the southern zone. And shortly after that, we had a derailment at Hoffield, which is the line down towards Ashford. CTR2 used to be called Boat Train Route 2. Probably one of the first times I met John Jarrett, actually, on this site. But the freight train derailed on Poor Top at Hoffield and dragged all the way through to Charing. So 2 miles of track were damaged in that one. And the investigation revealed the fault was cyclic top. And that's when an awful lot of work was done to, Mr. Jones will remember, we had diagrams of Kent, and we had late nights in the office working out where we had a cyclic top risk. And the particular vehicles involved were Continental ferry wagons fitted with something called Brunninghouse suspension. And it was deemed that they were susceptible to dips at 30 foot, roughly 30 foot, 9 meter intervals at anything around 40, 45 miles an hour. So effectively, if you had cyclic top at 9 meter intervals, dips at 9 meter intervals, if you like, that then meant that at 40 miles an hour, the suspensions got excited and the energy just built up and built up, and the things effectively started to fly. And that's exactly what happened at Hoffield. So after that, where we had cyclic top, then we put on differential speeds, 30 for freight, generally line speed for passenger traffic. So that derailment increased the knowledge of cyclic top faults. I was talking to Mark about cyclic top because we've also had Freightliners off, but they are more susceptible to longer wavelength faults, something around 18 meters, 60 foot, strange enough, which is the old joint spacings. They're prone to coming off at around 60 mile an hour if you've got dips at 60 foot intervals. Then in 1997, just a few months after taking on or merging the south and southwest, there was a terrible derailment at Bexley. This was a freight train derailment, and it occurred on a longitudinal timber bridge. Longitudinal timber bridge, for anybody that doesn't know, doesn't have any sleepers. So each rail is on a longitudinal timber, as the name suggests. The derailed train contained 100-ton aggregate vehicles off of a track renewal, and that pushed through the parapet of a viaduct and ended up in the roadway below. The cause was decayed longitudinal timbers combined with an overloaded speeding train. So this was the second major derailment after the Charing Hoffield one in Kent in the space of a few months, and it triggered a full review of the maintenance contractors' activities and a reorganisation of their track maintenance organisations. So this is the wagon, 100-ton wagon at Bexley, and you'll see that it's one of the 100-ton wagons. There were a number that were derailed. It's taken out the edge of the viaduct, and at that stage we had no idea what was underneath. The fire brigade brought in heat-seeking cameras to establish if anybody was underneath there. But they explained to us that heat-seeking equipment only works for a limited number of hours because the body soon gets cold. So I have to say that was probably one of the worst 24 or 36 hours of my railway career, until they managed to lift that train and find that there fortunately wasn't anybody underneath it. And there's an aerial view, and you can see here the longitudinal timber bridge. This is the down line where the train derailed and went down through the parapet and finished up in the area below. Absolute carnage, devastation as far as that goes. You can also see the damage that's been caused to the arches. It's a brick arch viaduct. So not only has it taken the parapet wall away, but it's also taken out a number of the arches on the viaduct. I think it's worth just reading some of the findings from the investigation. This incident itself led to the revisions in the longitudinal timber standard. So we revised that, and certainly one of my team that you'll be familiar with did an awful lot of work in as far as that goes, as did the maintenance teams at the time. Inspection and maintenance were in different parts of the maintenance organisation, and it didn't really come together until very high up in the organisation. And this is taken from the report. The failure of South East Infrastructure Maintenance Company to manage their organisation. SEIMCL did not have adequate systems or procedures and failed to provide sufficient resources to meet their commitments to ensure that the whole of the railway infrastructure in the eastern part of the southern zone was safely maintained. The longitudinal wheel timbers on Bridge 799 were rotten and had been identified as requiring urgent repairs by South Eastern IMCL. So the problem had been identified. The company did not arrange for any repairs to be undertaken, and the track continued to deteriorate until it eventually became unsafe. That was point A. Point B, Southern Track Renewals Company, who had been using the wagons and filling the wagons, failed to make adequate arrangements to ensure the wagons were in a safely loaded condition. And C, Railtrack have ultimate responsibility for ensuring that the railway infrastructure is maintained in a safe condition. They failed to monitor the performance of their contractor. The unsafe condition of the track was known of by Railtrack, but they took no action to address this. So all three parties there taken to court and all found guilty. Out of all these horrible things, sometimes you get some positives. When they did take those wagons away, they found a number of stolen Rolls Royces in the arches underneath. So there were a few people in there. I don't know if they were trapped in the arches, but they were quite red faced and not quite so good perhaps. But I hope you won't mind me saying, and I don't know if you're listening, Chris Rayner, who was the area manager of, would it have been in those days?
I'm not sure. The not maintenance engineer, but maintenance, yeah, probably contracts manager.
Contracts manager, possibly.
Like that, yeah.
Chris, being proactive in a situation like this, had seen a burger van on the A2 and wanting to set up on-site arrangements for the team that were working there, managed to get this guy from the A2 to come up and bring his burger van and set up site there. So there were free burgers for not only anybody that's working there, I think most of Bexley turned up. So that was great until the next day, and we found out that most of them went down with food poisoning. So there was a sting in the tail to the free burgers. Anyway, Bexley, I'm sure for a few of us are very sore.
That's the worst thing I've ever seen.
Yeah.
And there was just your point about the fire service there. I remember there was a point where they asked us just to stop everything, and it was completely quiet on the site, and they had just dogs going around the place, just trying to sort of listen if there was any noises coming from underneath. It's really quite horrific.
Yeah. Okay, moving on. Spa Road near London Bridge, in 1999, two trains collided and derailed after a Connex train spadded a signal and ran through a switch diamond, which was set against it, causing a collision. The derailment was on a multi-track viaduct through S&C on the approach to London Bridge, if anyone knows that patch. very densely populated part of London, and that was a very difficult recovery and restoration. I think he was on that one, Andy, wasn't he?
Yes, because we walked the passengers down the track back
Yeah.
towards London Bridge. Yeah.
Then 1999, this, I'm not even sure why I put this. This is a pretty nondescript one for some of the ones that I've been involved in. Bethnal Green, we had an on-track machine, a tamper derailed in a possession during tamping operations. And the investigation found that the 07 plus a tamper, as we were using then, was exceeding its lifting capabilities, which caused the frame to twist and the tamper to derail. So there are lifting limits on some of these on-track machines for a good reason. 1999, Strood Tunnel. A passenger train derailed in the tunnel on debris that fell from the tunnel. For those that don't know, Strood Tunnel is an old canal tunnel, and it is cut through chalk. And at the time, it was an unlined tunnel, so there were fissured chalk bits which often fell, fairly small bits. But on this occasion in 1999, we had a slightly larger bit that fell. And you can see there, and this is the tunnel portal, nobody was allowed in. The police were, like all these incidents, treat it as a scene of crime. But nobody was allowed in until Nigel Ricketts, who was the structures engineer, and myself, we were allowed to go in and just to see what the state was in there. As a result, it took a long way. It took a while to re-rail that one because of the confines of the tunnel, but we had a very long-term 20-mile-an-hour speed restriction through the tunnel. That tunnel's 3/4 of a mile or something like that. So a 20 speed at that sort of length has quite an impact on performance. And there was a further fall in the following year. It wasn't to the same size, but eventually the tunnel was relined. The tracks were squeezed together. The 6 foot is a lot tighter to give room for the lining, but we couldn't take that speed off until we'd give assurances to the ORR that everything was safe in there. And we couldn't give that until essentially the tunnel had been relined. So it was a big, expensive exercise to get that done. And also there was a number of blind shafts on the tunnel. And whilst we were carrying out some of the work, I'd say Railtrack were carrying out some of the work, so they're contractors. Someone's garden disappeared, and it turns out that they didn't know that there was a blind shaft in their garden, and they whatever was covering this shaft collapsed. Fortunately, they didn't disappear down it, but there was an investigation done into that, and there were a number of other shafts discovered that were in that residential area. So further work had to be done to prevent any further collapse of those blind shafts. Moving on into 2000, this is a Wessex one. 9:15 in the morning. That first bus was going across Pooley Green Crossing, which is on the Reading line out towards Egham. And the driver failed to check that the exit was clear and got stuck on the crossing. The barriers came down, and he fortunately got the 9 passengers off of the bus, but he wasn't able to move the bus until the train hit it. So that train hit the bus, and you can see it in both pictures, the bus there, very badly damaged, but the bus actually went into a house and demolished part of the house. I don't know if it used to be a crossing keeper's house that's there, but it caused significant damage to the house as well. Lucky there were no serious injuries on that, but that was, say, 9:15 in the morning. I think I got back to the office about 7 or 8 o'clock at night after being out on that one. Anybody know what else happened that day? Hatfield, the Hatfield train crash. So while Wessex had its own relatively little accident. Then on the same day was Hatfield. So on my call back in the office, we started to search through the records of what we knew to be gauge corner cracking or rolling contact fatigue defects. So I'm sure most people are familiar with Hatfield, but Hatfield, a passenger train derailed on a broken rail caused by rolling contact fatigue. It's not a good picture, but the lower picture there is from one of the reports, and it shows that the rail at Hatfield shattered into over 200 pieces. And that is one of the big risks with rolling contact fatigue defects. They are cracks that are very close together. So if one breaks, the likelihood is the others will shatter as well. And we did know limited amount about rolling contact fatigue at that time. There were some sites identified, but we didn't understand how severe it could be. And like a lot of other track engineers around the country, all track engineers, I think at the time, we were all called in to support the investigation and to find out what the rest of the network actually looked like as far as how many sites were there. And the problem with RCF is some of it is very clearly visible. The defects at Hatfield were clearly visible. They were known about. And we had records of a number of sites that were known about. But actually, when you start to look very closely at rail, you start to see RCF that wasn't clearly visible. And that's when we started to get really concerned and to understand the scale of the problem. So the team in Wessex worked very closely with the team at the rail track HQ. And we put instructions together. Initially, it was PWSI 1 through to 4, permanent way special instructions 1 to 4. And now the output of that sits in 001, the track maintenance standard. I think it's true to say that was one of the incidents that has changed the management of track as far as track engineering goes. Clapham was the same. The Clapham disaster was the same for the signalling world, and this was true for the track world. At the time, there were so many speed restrictions on around the country that we almost brought the country to a halt. And from a rail point of view, we did. We were having to import rail from the continent. We undertook a huge re-railing exercise like was never done before. We were getting rail from not only the British suppliers, but we were getting it from France. We were getting it from Italy. Some of the Italian stuff was crap actually, but it was better than what we had. Lucchini, who incidentally make the majority of the wheels that we get in this country as well. Well, actually not in this country, but around the world. They're one of the biggest wheel manufacturers. But they had problems with their manufacturing plant for rail at the time. So that what they were supplying us wasn't the highest quality, to be fair. That went on for a long while. We were feeding Railtrack HQ. We had to feed our input of the number of different sites, new sites that were found each day to the centre, the number of speed restrictions that had gone on, the number of speed restrictions that we got taken off, the amount of re-railing that had been carried out, and estimates of when we'd clear the speed restriction. Of course, it was a finger in the air sort of thing. And those figures were reported daily to number 10 Downing Street. So they were really being escalated up to the highest level. And we were getting a lot of pressure coming down from 10 Downing Street as well, who weren't impressed with the way the railways were running at that time. I was also called as an expert witness for the prosecution and appeared in court at that case. I have to say that is one of the worst, one of my worst times on the railway. I was told that I'd been nominated, so thank you for whoever nominated me for that. Just before our Christmas party one year, and I have to say I don't remember much of that Christmas party after that, because I hit the bottle out of frustration.
Well, before you go on from that,
Yes.
I got a little bit involved on the side of that, although I was not working for rail track.
We were getting all your S&C, Jim.
Yeah, I had been on an inspection for Bedford in the sidings there a couple of weeks before, and I criticised this condition of the sidings. It takes you back to what you were saying earlier, and I looked at not just the sidings, but I walked out onto the slow lines just to see what the rest of the S&C looked like. Well, the rail track guy, who was local, who I promptly got in contact with because I said it was in a terrible state and it'd be in trouble. He said, there's nothing to do with you. Your contract was to look at the depot, not anything else outside the depot, and anything you did out there, you don't do it again. Mm-hmm. Well, I was from that visit, I went over to East Coast Main Line to come back south rather than using the Midland Main Line just for a change. Mm. And the upslow train that I was on was stopped on the upslow on the curve right there for the fast to come through before we went fast line. And I looked out at the rails. I was looking mainly at the up fast, not the down fast, but I had never ever seen railhead like it. It was 50% of it was black because the grease was filling the voids, the holes in the topsoil. I mean, I've never seen a rail like it before or since.
And I think there's a message there. Yeah, there's a message there, Jim, that if anybody finds anything that they're not happy with as a track engineer, then take the right action. And clearly in the case of, I won't go into all the details of Hatfield, and it's worth reading the report, but there was pressure put on by senior managers not to take action, to keep trains running. And of course, we always want to keep trains running, but we want to run it safely. Yeah. So as a result of Hatfield, I think at the time, the number of breaks that we were seeing around the country were around about 960, 980, close to 1,000. As a result of what we've learned from that, and we've learned an awful lot, today or recently, the number of breaks is less than 100, which is a fantastic achievement for everybody involved in that. Things that changed, we were doing no grinding then. Railtrack didn't want grinders. I think we had a Spino grinder for 6 months, one Spino grinder for the whole country for 6 months of the year. And there was no policy what we should be using it for. We had probably one ultrasonic test unit, but it was up to the local team whether they wanted it or not. I personally had a lot of success on the LTS with the UTU, so I really wanted it, but it was seen as a nuisance. It found too many defects, so encouraged not to use it. So since then, we've invested heavily on grinding trains, now milling machines, UTUs, ultrasonic test units. There's a lot more of those. So all in all, and with the re-railing and the change of standard, it's really helped to improve things. West Sutton, passenger train derailed on wide gauge, which was on Pan 8 track. If you know Pan 8, it's a lock spike fastening, that goes down into the timber sleeper, and the spikes corrode at the interface of the base plate and the timber, so you can't actually see where they've corroded. So you're looking for witness marks, shuffle marks, and things like that. As a result of it, I think the Southern probably had the largest share of Pan 8 base plated track. So we did a lot of renewals. I think there's probably still some Pan 8 around in places, but nothing like it used to be. And we introduced something called the Titgemeyer screw, which is a screw that would fit into the square holes that the spikes fit in. So when I brought that in, I really should have invested in the company. I didn't, unfortunately. I attended court on that one. We were prosecuted under the Health and Safety of Work Act. I didn't have to go into the witness box. So lucky as far as that goes. But Railtrack were fined 30k and AMEC fined 40k, both plus costs, which actually seems like peanuts today. But so another few Longhedge Junction engineering train. I think that was a small wagon. The leaf spring failed, and it was poorly loaded, so that tipped over. Charing Cross derailment, another one on longitudinal timbers. This is on the where it goes across the River Thames. Again, wide gauge on longitudinal timbers. So the same themes regularly come up. In this particular one, the cleats that retain the timbers were corroded and there were no transoms present. And I remember that night on that bridge, I was on there all night. That was the night that the Queen Mother was lying in state just across the road in Westminster Palace. So that was around the time that she sadly passed away. And then we had Potter's Bar, which was another terrible tragedy. My involvement in that was doing some investigative reports on work on stretcher bars, and we actually tried some different stretcher bars down at Eastleigh on Wessex Patch. For those that don't know, the Potter's Bar incident derailed on a set of switches, doing 100 miles an hour. You can see where it's derailed on these switches here. It's flown through the air, hit there, and then the train is on its side through the platform at Potter's Bar. And I think 7 killed at Potter's Bar, as well as a lot of people injured on that train. Then 2003, we had Merstham Cutting, train derailed on a landslide in the steep cutting on the Brighton main line during a period of very wet weather. And we had a similar one that occurred close by in 2007 when a root ball fell, forcing the King Post wall. And this is the photo you can see there, the root balls behind this King Post wall, and it's pushed it down, and that's derailed a train there. Fortunately, nobody seriously injured, but a very awkward cutting to gain access to, get passengers out of, and also to carry out the repairs. And a lot of work has been done on that cutting since to stabilise it. Particularly difficult geology through there as well. The top layer of that is very susceptible to washouts. Then 2003, again on the Brighton main line, we had a Gatwick Express derailed. It was the first train up in the morning after work had been carried out. And you can see the misalignment there. Part of that was caused by the derailed train, but there was a significant misalignment. That's a 90-mile-an-hour piece of track. The Gatwick Express came along and hit a misalignment. And the misalignment had actually been caused by the tamper. This is another one that I sat on the investigative panel. The tamper actually stopped its work where that misalignment is. And they checked out the back of the tamper, and the alignment running up to it was fantastic. The alignment forward was fantastic. But what they hadn't picked up is that in achieving this good alignment on the work that they'd done, they'd picked up a slew. The tamper had started to develop a slew, which had run out in a very sharp transition underneath the machine. So one of the things that recommendations that came out of that is that whenever you are doing tamping operations, that you always pull the machine clear of your site and inspect underneath it and all around it. Again, nobody injured seriously injured on that one. Very, very fortunate. Willesden High Level, train derailed on a sharp curve on gauge spread. Another gauge spread derailment. Clapham Junction sidings. This was Malcolm, you might remember this one.
Yes.
Overturned a Kirov truck crane whilst carrying out lifting operations. I had some photos of this, but there was a member of staff sitting on the jib of the crane in the photo, and I thought it wasn't appropriate to put that there. But the crane overturned.
That's not, I'm sorry, that's not true, actually. That's not true.
Is it not?
No, it was the safety system was disabled by the operator and the supervisor on site. And then the crane was able to slow further than it was capable of doing. That's what tipped it over. It's nothing to do with the outriggers.
But
There
the
were no
outriggers
outriggers out. There were no outriggers out.
Were they not?
No.
Oh. Oh,
Sorry, I don't
No.
like this.
Appreciate that. Thank you. It's good. I'll correct that.
And it resulted just as a matter of interest, it resulted in really positive instructions about the disabling of the safety system.
Yeah.
The operator cannot do it. The key is taken out of the crane and is kept with the supervisor.
And that's good that.
Yeah.
Because I can remember days when we had the general purpose cranes, and we often used to stuff some gloves into the horn to stop it making, and somebody would keep an eye on the back wheels to make sure they're not lifting up and things like that. That was the safety system.
You don't disable the safety system, it can't overturn because it stops itself. The hydraulics stop it.
Yeah, brilliant, thank you. And then on the limiting branch that year, we had a ballast train derailed in the possession due to severe track twists following track renewals. I think there was a lot of ballast dropped as well. I haven't covered any derailments that have occurred through excessive ballast being dropped, but that was fairly regularly an issue in early days of track renewals. 2004, we had a blockade on the Wimbledon Loop, so not a million miles from where we are here. This was Sutton Common. This was a track buckle. The train derailed, and there's the derailed train in the picture there, on that track buckle. Now, the buckle that you can see in the photo was probably made worse by the train hitting it as well, but there was a track buckle there. And the real cause on that one is a real lack of ballast, as you can see, on a downhill gradient where trains were braking, and effectively there was nothing to stop longitudinal movement on that new track. I can't remember if that had actually been stressed or not at that stage when that happened, but it just proves how critical ballast is to prevent longitudinal movement and then a build up of stress in situations like that. It was pretty warm as well. Another one at Spa Road Junction, passenger train derailed on S&C, again a SPAD, and ran through a switch diamond, which is set for a conflicting route. And you remember that case called Hatfield? And you remember I was told that I had to go for appear in court. Well, this is 5 years after that. It's 5 years of thinking about I've got to appear in court till the actual case occurred. So I was called as an expert witness. The evidence involved 10 rooms full of bundles of documents. And I was questioned. You get told roughly what the questioning is going to be, but not all of it. And when I was in the dock, one of the QC brought out some minutes of a meeting that I'd chaired 5 years earlier and questioned what was meant by those minutes. So it's really important if you're chairing meetings that you keep good records of what's, because you never know when you're going to need those. Just of my appearance in court, and I was only in the witness box for a day, there were 146 pages of transcript from my appearance. Some colleagues, well, a lot of railway personnel were in the witness box for much longer, and it was really terrible to see some of the ways some people were suffering as a result of that. Yeah, we're coming back to Wessex again. 2006 wasn't a good year for Wessex. In September, we had a derailment at Waterloo. Empty coaching stock derailed on facing switch when entering the siding. Switch had been poorly machined following reprofile. So it had just been ground, and the profile wasn't good. And then in October, so a month later, we had a second derailment. This one was a passenger train. I think the first one was coming out of 5 into the sidings at Waterloo. The second one was going into 2, I think, on the up direction. This derailment was caused by a poorly profiled switch with a lack of lubrication. So following this, the standard for managing derailment risks at switches 053 was revised again, taking into account the findings from these 2 and other derailments on switches. And that photo there is the second derailment. So that, yeah, the first one shows the route out of 5 going into the downsiding, and it derailed on 2565s, I think. I'm not even sure if that's the same point number now. And the second one was coming up the up main slow and into 2 and derailed on that points there, 1507s, I believe. It was one of the few RAIB reports that covers 2 accidents. So, you know, some things you want to be in the Guinness Book of Records for, but that's not one of them. And then in September as well, at Epsom. So again, Wessex, passenger train derailed on S&C. The point of derailment was established as the very heavily side-worn and wide gauge dry rails on a sharp curve. So again, really critical that gauge is managed, lubrication is managed to keep on top of these things. And that you can see there some grinding marks. So there's some recognition how bad the joint was and the sideware was, and running into a section with poor sideware or lack of sideware, and also the swarf that had been building up there. Whether that is swarf that's come from wheels or rails, not really sure. We didn't do that sort of analysis. I think it's probably worth reading. Have I got the? Oh, I didn't write this out, but so there were issues around the organisation again on this one. 2007, quite a spectacular derailment this time. By this time, I think I was territory engineer, so they'd merged South and Anglia, and I was then the territory track engineer for the Southeastern Territory, as it was known in Network Rail days. This train derailed, we thought originally on a twist, although we couldn't actually get the twist to severe enough to what we thought would derail a train. But this derailment partly demolished the bridge over the Great Ouse and shut down a lot of the river traffic as well. We were fortunate enough that there was a wheel impact load detector, a wild detector, installed on the line approaching Ely. So this train had gone over it, and the wheel impact load detector gives you, you can see here, each of these lines is actually, there's another diagram that shows you each of the lines for the load, so you can work out what loads is in each load. And this one gives you a variance in loading on each of those wagons. So you can see here, these two axles that are below the line indicate that that vehicle was, one, badly loaded, but also twisted. So the actual subframe of that vehicle was twisted. When we looked at the twist information, we took some dynamic. The twist was, I think it's the far figure on there, 300 and something. Oh no, sorry, that's the radius.
It was only an alert limit.
It was alert limit. It's 373, I think, or something like that. Well, actually 500, 512. Yeah, that wasn't anything like we thought. It's on a fairly sharp curve, but fortunate that we had that wheel checks information, because that actually proved what was the cause. And if we'd not had that, one rail track would have had to spend a lot, Network Rail would have had to spend a lot more money on the rectification. I think that went to an insurance job. 2008, Marks Tay Freightliner train derailed on track that had poor geometry and voiding. Windsor and Eton Riverside passenger train derailed, wide gauge again. This particular one is right opposite the Queen's entrance to Windsor. So I'm not sure she was in residence at the time, but she probably wouldn't have been very amused if she read the report. But it just highlights, platforms, terminal platforms, as this was, the need to inspect those as diligently as anywhere else.
That's been re-gauged. It's hasn't been plugged and they pushed through. I think that's that one.
Is that one? Yeah. Yeah. Thank you. And then I include this as depot. There was lots of depot derailments in those days, but incorrect operation of points, which was often the case in depots. They used to run through without checking them. Train was partly through, they'd reverse it back out, and the switch would spring the opposite way. In 2012, I became the IMDM depot manager at Romford, so responsible for Liverpool Street, Fenchurch Street, and the tracks there, and on all the maintenance. On the 23rd of January 2013, I got called out to a points failure. Now, it's unusual for the IMDM to get called out to a points failure, but for Steve Hooker, if anybody knows Steve, he was in the office and I was there at Liverpool Street. He said, "Got a points failure at Liverpool Street." He said, "The S&T are out there and they think there might have been a derailment." Well, there's no train there. Normally on a derailment, you expect to see a train. Yeah, I'd seen that one at Temple Mills Depot where a train jumped off and cleared off again. But normally you expect to see the train. So he said, "Go up there and see what they're on about." He said, "They don't want to sign it back in." I went up there, borrowed his boots. He never got them back because I tried him quite early. Liverpool Street was a horrible place for all sorts of reasons. So what happened here was a passenger train, a Norwich train, derailed on the Switch Diamond, in this area of the Switch Diamond. And that is something like 150-metre radius curve. So normally on that sort of radius, you'd expect we wouldn't like to design to that sort of radius, ideally, but it is a very confined site. But you'd normally expect to have check rails on that sort of radius. You'd expect it to be gauge widened. This was gauge widened, but not by design. Because it's a switch of a Switch Diamond, clearly you can't put a check rail in there. So it's an area where it's going to be particularly vulnerable. And unfortunately, we'd not identified just how vulnerable that is, along with other places in Liverpool Street. The train itself actually re-railed just here on a trailing set of switches, or the heel of a trailing set of switches, and then went on its merry way to Shenfield. A number of I think I've got a feeling part of the ceiling came down in one of the coaches. because of the rough ride, but the passengers were reporting a rough ride to the guard. So the guard got hold of the driver and said, "We had a really rough ride when we left Liverpool Street. Can you report it to control?" So they stopped the train at Shenfield at 20 miles down the line. The driver got out, looked back, everything was on the track. Couldn't see anything, so he proceeded on his merry way at 100 mile an hour to Norwich. It's only when the engineers at out of Crown Point Depot at Norwich got to look at the train that they saw marks that clearly indicated that there had been a derailment. And of course, by this time I was on site, and yes, there had been a derailment. So this is one where a train jumped off and jumped back on again. You don't see many of those in your career. You don't want to either. It drove a host of things. I mean, we got the inspection vehicle commission for looking at S&C in terminal stations, because parts of this are not covered very well by the track record. There's so many different routes. So we had to commission a special vehicle to start looking at these sorts of things. And we went through almost, well, I think we did bearer by bearer, measuring the gauge and the condition. Actually, what they found when they looked at the train was, I think, it was 125 metre radius, so it was sharper than I said. That actually you can see the wheels in red. All of those had evidence of being derailed. So there were 18, I think 18, 18 wheels that had derailed or very nearly derailed and a jump back on. So an incredible derailment, but an interesting one. Obviously, Paul looking at his watch. Clapham Yard, delivery of a new rolling stock. By this time, I'd left Network Rail and I was doing some investigation. And this particular one, I was doing it for the PWI asked me to if I could do this one. The bullhead turnout, the bullhead keys in the check rail had failed to keep the check rail in the correct place. The check rail had moved along, and as a result, the nose wasn't adequately covered by the check rail, so a loco derailed on that. I was asked to attend this one on behalf of the freight operator to identify the cause. This is Hazell in Birmingham. Freight train derailment. It derailed in the sidings at Hazell, which are privately owned. This one was a wide gauge derailment and dragged out onto Network Rail's infrastructure. So this is where it's finished up here. This is Network Rail's infrastructure. And the evidence and the witness marks are quite clear. You can see the shuffle here and in that photo there, and also the chair screws. You could pick them up and lift them out because they'd sheared. It's quite a common place for them to shear below the top of the sleeper level. They'd corroded away and sheared as a result. So a thing to look for with sharp curves in particular, these shuffle marks, and that's a very clear one, but they're not always that clear. And the tops of screws projecting from the tops of the base plates. 2019, I was engaged by the Hong Kong government. This was the one where I was asked if I had any experience in derailments. I had to list them out for my CV. I was going out there to do an audit, track audit, but this derailment occurred in the meantime, and they're not used to having derailments in Hong Kong, or they weren't. So I went out to this one. This was caused by a wide track gauge following maintenance activity. The hardwood bearers were the worst condition hardwood bearers I have ever seen. I've never seen hardwood bearers fail in that state before, and they clearly had a lot of work done to them in the past. You can see this one here, it's completely rotted away. There's some sort of resin that they've tried to patch things up as well in the past. But also you can see the screw holes here, how that's clearly been elongated and given wide gauge. You can also see, you know, there's inserts that of VV coils that have been used to try and stop the gauge point. So there's a known problem there. This occurred in the gut rails of a turnout, the wide gauge, but the wheel then hit the check rail and rode up, and you can see the way it's smashed here. And this here is swarf that indicates that that's been happening for a long while. They had put the cause down as the wheel striking the check rail and not identified that the root cause was actually the wide gauge before. So a very interesting one. And it was due to maintenance, because what they'd done, they replaced some of these with composite bearers, plastic bearers, and those plastic bearers had been very good at keeping the gauge, but the screws, they hadn't replaced many, they'd only replaced a couple, and those screws sheared on the composites, and of course the adjacent timbers weren't keeping the gauge, so the whole thing just
the extra force on.
extra force, yeah. They were only using a couple of screws to hold the thing down. 2020, Wanstead Park, another longitudinal timber derailment on this bridge. You can see the state of the timbers underneath, which wasn't evident. This is we did some tests at Leigh-on-Sea, took them back to Leigh-on-Sea depot and did some testing on them. But actually what Rabe hadn't picked up was there were marks before that, and I looked at this track coming up to him and asked them then to look at it, and they investigated further and found that there were issues with the wagons. So whilst track was one of the causes, the actual bearings, the rotational bearings on the wagon had been seized, or were seizing. 2020, I said they didn't have many derailments in Hong Kong. This is Hong Kong light rail. And I was called in to review best practice of light rail around the world. They've got something called an outside check, which I'd never come across before. This check rail is on the outside, pushes the wheel back to minimise wear on the switch rail. Whoever invented that, I really don't know, but not a good idea. That had become worn. The angle of attack then hit the actual chamfer, and the wheel rode up on it and derailed as a result. So not one to really learn from in this country. This was London Gateway, one of the few that actually we had a video of. And if you watch, this is the security guard's view of the CCTV cameras. It's speeded up to start with, but then slows down. It's just at Christmas, you can see the Christmas lights flashing in the background. Here comes the train, and then it's the cameras are slowed down. And it all goes a bit funny there.
Yeah.
So I was called to investigate this one on behalf of an insurance company. I've got to stop this now. And it was the design of the wagons. The track itself was pretty much perfect. There is a very slight misalignment which was caused by the derailment, not a cause of it. But nothing at all could you put that down to the track. Rabe did a very detailed investigation on that and found that there were issues with the wagons. So it's quite that is actually quite an interesting one to read. And then 2022, back in Hong Kong again, station called Yai Mai Tai. a passenger train was derailed by a fallen structural component within the tunnel. So on the left there, that's forward-facing CCTV, and you can see there something lying across the track. And that something lying across the track is a derailment guard, which should be in front of this large ducted fan on the right-hand side. So there's a bored tunnel. It comes out of a bored tunnel into a cut and cover tunnel. In between those two was a derailment protection guard to protect the fan equipment. Sadly, what they've not done is inspected it. It wasn't on an asset register. The fasteners, that was actually quite damp around there. The bolts holding it down, it was a cantilevered arrangement. The bolts holding it down had corroded away, and the thing actually fell across the tracks. And I was called in to support the investigation and try and identify other locations on the MTR network that may have anything of a similar risk. So we looked at all sorts of structures surrounding the line. And then 2023, just before Christmas, I think this was the actually just after Christmas, 27th of December, at Hazell, in northern Sweden, there was a derailment of an iron ore train owned and operated by the mine company LKAB, which is a Swedish government-owned company. They own the trains, they operate the trains. The trains themselves are 32.5-ton axle load, so they're big, heavy trains. The train derailed, and there were 15 kilometres of track damaged, 25,000 sleepers, 3 turnouts, and a snow shelter. And this is in one of the snow shelters. This is a turnout, so you can see what happens if you get 32.5-ton axle loads, derail, cut through a rail, and bending the check rail there. This was a relatively new turnout on concrete bearers. Now the derailment itself, that 15 kilometres, 14 kilometres, only had damage on one side, which indicates that there was an issue with the wagon itself, because there's no derailment on the other side of the track. And here you can see the offending wheel. This is still subject to formal investigation by the Swedish investigation authorities. But you can see here that the one of the wheels has moved on the axle, and as a result of it became derailed. That's a bit of the wheel on the very right hand side there. On the left you can see the wagons stacked up, because the derailment was quite controlled for the first 14 kilometres. It was causing a lot of damage to the plain line, but until it hit S&C, then like normal, then the wagons just go all over the place, and that's exactly what happened here. And you can see they effectively stacked themselves up, and that's within what was a snow shelter, so built to protect the snow. This is the one I don't know if the video works, Paul. Oh yeah, here we go. We're nearly at the end. So 27th December, derailment occurred. This is the first train after the derailment, 20th of February. So what a great sight that is, to see that running after all that time. You can imagine how difficult it is to do track renewals when I was out there, it was -27. We would never normally consider tackling a track renewal. Just actually finding the cause, you had to clear the snow, and the snow was so heavy. It was well, I'd never encountered anything like it. So I was asked by the insurance, was it reasonable timescale? Every day that line was closed, it cost the iron ore company $10 million in lost revenue. So you can see the sort of how it builds up. So that was the 20th of February 2024. I had to buy a new coat, yeah. 27th of February, there's another derailment in Vassiliere. I was called out again. This was a lot warmer. This was -9. They believed there were two things. There was suspicion because one, the mine is the largest iron ore mine in the world. The second largest is Russian. And also that week, Sweden had joined NATO. So there was a bit of suspicion going on whether there was anything strange happening. So I went out there again to support the insurers and the loss adjusters. This train was empty, whereas the other one was fully loaded. And in fact, even in a loaded state, they had reduced the loading and the speed because this was part of the not where the derailment occurred, but part of where the derailment ran through was a track that they just replaced following the previous derailment. And if you remember, the East Tilbury derailment was caused by snow. Well, this is the second one in my experience that was caused by snow. They brought the train to a halt in this snow shed while they cleared the snow from the station area in front. So they're very well equipped for clearing snow. However, there were gaps at the top of the snow shelter and it was horrendously windy and it was blowing an absolute gale. Snow came in and I always thought a snow shelter was to stop snow, but you can see the amount of snow that was actually in that shelter and the ice that formed on the right hand side. That had got underneath the wheel and just lifted the unloaded wagon off. So again, subject to formal Swedish investigation, but that was my last experience with derailments. So hopefully shared some of that with you and some of the lessons learnt from that.
Thanks very much.
Thanks.
Thank you very much.
Any questions?
So how are we doing for time, Paul? We're a bit over, aren't we?
Yeah, you kind of, depends how long you want to stay, really.
Yeah, absolutely, members of the audience. So
About 10 minutes. Or...
yeah, let's finish at 6:45 then. Yes, so we'll try and do 10 minutes of questions. Paul, did you have your hand up?
No.
You were just drinking.
Well, going back to that Waterloo derailment, the second one going into platform 2, you said it was 1507 points. Now, I don't know whether that's triggering my memory or not, but I recall about that time there were problems with replacement switches for Waterloo where they were not wrong-handed.
Yeah, I'm not sure about the wrong-handed element. There were some wrong-handed switches at Waterloo. Certainly, it didn't have the correct curvature dressed into the stop rail when that was replaced. So yeah, there's a crossing in front of it. Crossing goes directly onto the front of the stop rail. Horrible alignment there, which effectively triggered the failures.
Because if it's not been correctly wrong-handed,
Yeah.
then you've got an even sharper.
Yeah, absolutely.
You touch the switch tip.
So it's really important to check the drawings when you're ordering S&C, because some of these things are not always obvious.
What else?
Could I just clarify something on Bexley, which is fascinating, and I've worked in that area actually, so I brought up in that area. But there were no deaths on that at all.
There were no deaths. There were 4 serious injuries, I believe.
Somebody break their leg under ground level.
I don't know. There were 4 serious injuries and no deaths. And one of the things I didn't say there is the real problems that we had to source skilled bricklayers that can actually reconstruct an arch. Because we were talking about bricklaying earlier, how difficult it is to get a straight line with you imagine trying to reconstruct an arch to how it was built 150, 140 years ago. There's not that much expertise in the country now to do something like that.
lead to a big review of the long timber or wheel timber.
Huge, yeah.
There was a particular feature of the wheel timbers there, in as much as they wasn't one timber.
To the short ones.
No, well, it is a very old-fashioned thing that used to have to make them easier to put in. There were two timbers longitudinally with a wedge in the middle,
Oh, really?
and then a topping piece on top, which we'd never do nowadays.
Well, I'd love
But
to see one of
we
those.
tolerated it up until then.
In a museum.
Yeah, yeah.
Well, I was running the sort of review of the LT timbers at that time with my track colleague. So I'm very interested. Thanks.
We got any online questions for you?
There was one asking about tampers, which thankfully we've got a bit of an expert watching online in terms of Simon Booth, who's actually answered the question online.
Thank you, Simon.
About qualifying the handback arrangements. Simon has gone on. Thank you as well, Bob, for sharing your experiences with that. There was one other question about just root causes, well, underlying causes or contributing causes of wide gauge derailments. But I think at the time the question was asked, you've gone on and given illustrations of various causes of wide gauge derailments anyway. So I don't think it's worth repeating the question particularly. I think based on what's been asked, I think you covered that more than adequately.
Well, for me, on that portrait, wide gauge, and we had a really fantastic paper some time ago about Eastleigh, didn't we? Thanks, Andy, and your colleague at the time, and that was all about gauge issues and train movements, wasn't it?
Yeah.
So thank you, Bob, for reminding us all how important that is.
I think we might have one from Mr. You don't often get this on a chat from Mr. Furnival. I think this is from Paul Furnival. I've got one about snow ploughs he wants to ask. It's not a question you have, so I think we should at least give him the opportunity to ask that. So far away, Paul.
Hello, Bob.
Hello, Paul.
Hello. Talking about snow, I've had 2 snowplough derailments this year already with no snow. So you have them with snow. I've had a snowplough that's derailed twice in the West Yard due to snow.
Really?
Yeah, we've done some investigation. It was a B set of switches in the West Yard, and it was on the tight radius. So we think it was around 200, 220 metre curve. We can't find any evidence. No one can tell us what the design radius of a free-wheeled bogey is.
Snowplough. Yeah.
Snowplough. And evidently, chatting to Paul Fleming, last time it was moved in 2019, it derailed as well. So 3 times in the same yard on the same set of switches. You wouldn't have to know where to find out what this working radius is, because they can't find it even in the design drawings.
What you need is a good consultant, Paul.
Uh,
but I wouldn't know where. I mean, I'll look online, but I'm sure you've all done that.
yeah.
Find in the Eastleigh derailment that you just mentioned there, Paul, was that we had a dynamic analysis done of the forces, because the diesel loco concerned had got a triple axle bogie, and the gauge spreading force on the leading axle of a triple axle bogie is very, very much higher than a double axle bogie, and that certainly contributed to the Eastleigh derailment. I'm not saying it was in any way out of standard or anything like that, but it's hugely more gauge spreading force.
Have you checked with rolling stock colleagues, Paul?
Yes, we've got all the design drawings for it, but nowhere does it mention what radius it's suitable travelling over. And it was only ever the front wheel derailed, and the rest of it stayed on. It just hopped over the rail and carried on running, bouncing along the top of the chairs. And it was because I think it's just not enough weight to hold it down. On such it just there was no side where there was no twist.
Very heavy. Yeah.
The centre axle would normally have lateral plate.
Yeah.
And because it's so little used, I wonder whether that seized up.
Yeah, it could be that the lateral plate is seized up, however that's whatever bearing form that there is on that.
Yeah.
Bob, is this one of the snowplows that was based on a
English Electric Type 4 diesel bogie, motor bogie.
Yeah.
Is that class 40?
Yeah, class 4, sorry, modern speak,
Yeah,
class
so
4.
ZKA is the type of unit, I think.
And yeah, they were built onto these bogies. The front axle, which was a carrying axle,
Small wheel, wasn't it?
was a small wheel. So they were originally 1 Coco 1
Yeah.
diesels. So that must have altered the weight distribution on the bogie for starters before you put the superstructure on it. Presumably the snowplow superstructure is a lot lighter than the very, very heavy diesel. One of the most the heaviest diesels that BR ever built. I'm sure there'll be a lot of opportunities for consultants to have a look at the,
I'll give you my card, Paul.
Yep.
The other opportunity, Paul, thanks very much for your question. The other opportunity is once you've got to the bottom of it to come and give a presentation on the subject.
Oh, good to hear you too, Andy.
That takes us right up to 1:45. So thank you very much, Bob, for that fantastic tour de force of a presentation, and well worth the small overrun.
I've had worse overruns as well, but that's another presentation.
They were probably my fault. So yeah, we've learned a tremendous amount there, and I think just picking up your point, Paul. So if you look back in history, wide gauge is public enemy #1 over and over again. It's not necessarily caused the sort of worst derailments, because things like Bexley and Hatsfield and Potters Bar are truly dreadful, high speed, nasty high speed things, not Bexley high speed, but things that happen at high speed are absolutely appalling, and the amount of damage that can be caused. But in terms of just sheer number, wide gauge takes it every time, doesn't it? And thanks for avoiding Britain for the last 5 years as well. that was quite it. So let's give her another round of applause. And we'd like to inspire to
the local Wetherspoons, which is the Wibberstown, which is quicker if you walk around by Dundonald Road. Trams, people have got Google Maps on their smartphone. It's easily navigable there, to a couple of turns to take around there.
Okay, thank you very much.
I'll give you their short ones.
Thanks again. Thanks.
Thanks.